Hello everybody, thank you for watching. This is our 11.4 Introduction to Phase Changes. And if you remember previously, we have three states of matter. We have a solid, we have a liquid, and we have a gas. So in order to go from a solid to a liquid, energy needs to be increased. Going from a liquid to a gas, energy also needs to be applied. So what we can say is that gases have more energy than liquids, and liquids have more energy than solids. So what type of energy is being applied? The type of energy that is being applied from going from a solid to liquid and a liquid to gas is heat energy. And what's happening is going from a solid to liquid, that reaction is said to be endothermic because it's absorbing our heat energy, and that overall is going to result in a positive delta H. Going from a gas to a liquid and a liquid to a solid, that reaction is exothermic because heat is being released, ultimately giving us a negative delta H. So what we can do is take our states of matter and our phase changes and turn that into a diagram. So this diagram right over here is a phase diagram for water. And on the y-axis we have temperature, and on the x-axis we have heat. So in these diagonal portions right over here, it's important to notice that your temperature is increasing in these sections. So we're increasing in our kinetic energy. So the more kinetic energy, the more temperature change that we have. So more heat is being applied into these sections. We know that this is a diagram for water because water melts at 0 degrees Celsius, and then also water's boiling point is 100 degrees Celsius. So what happens during these diagonal portions? Because we have a change in temperature, we can calculate the amount of heat that's being applied and the amount of kinetic energy that is increasing. And we talked about this already. This is our specific heat formula that we need to use, where we have Q equals mc delta T. So now let's focus on these flat regions right over here. So this is where our phase changes occur. So right over here we have solid water turning into liquid water, and that's undergoing melting. Right over here we have liquid water turning into gas, and that's undergoing vaporization. Right? So there's a couple things to notice at these flat regions right over here. The first thing is our temperature is not increasing. So the temperature is staying constant. So what that means is that there is no kinetic energy that is being applied in these flat regions right over here. And that seems a little odd because you're adding heat, so that should mean that your kinetic energy is increasing. So what's happening to all that energy? During these phase changes right over here, because there's no change in temperature, all that heat is actually being absorbed as potential energy. So those molecules are only just being more spread apart. And that makes sense because liquid water, those molecules are more spread apart than our solid water. And our gas particles, when they're undergoing vaporization, are more spread apart than our liquid molecules. This phase change right over here has a specific name, and the name we call is fusion. And then going from a liquid to a gas, we call that vaporization. And if we wanted to represent this using our delta H, we can say delta H sub fusion is this phase change right over here, solid to a liquid. And then delta H sub vape is our phase change going from a liquid to a gas. So we said that temperature does not change. So there must be some sort of way in order to calculate the Q, the heat. The formula in order to calculate the amount of heat energy that is being applied during a phase change is m delta H. And our delta H can be fusion or vaporization, depending if you're going from a solid to liquid, which is fusion, or a liquid to a gas, which is vaporization. So this is the formula that we're going to use for these diagonal sections right over here. So this is just the definition of heat of fusion and heat of vaporization. What this means is it's just the amount of energy it takes to melt 1 gram of a substance. Heat of vaporization is the energy it takes to vaporize 1 gram of a substance. You might want to pause the video and write these 2 definitions down. So in a brief summary, we talked about a couple things in this video. First thing we talked about is that phase changes do not have a change in temperature. Therefore, there's no kinetic energy. Heat is being absorbed during these phase changes as potential energy, right? In order to calculate our diagonal sections right over here where we're having a change in temperature, we can use this formula right over here, which is our Q equals mc delta T. Our phase changes, because they do not have a change in temperature, we can calculate the amount of heat during that phase change by using this formula right over here, where Q equals m delta H of fusion or delta H of vaporization. Thank you for watching.